Okay, so to solve this problem, so first I'm gonna make a substitution. So I'm gonna call the ln of x equals u. Then I'll compute the du. So du equals derivative of ln is 1 over x dx. Okay, that will change this integral. So you can move the 8 outside. That will change this to du over square root of 64 minus u squared. And this is a trig integral. So we're going to solve this by trig substitution, the rest of them. And then I'm going to make another substitution here. So I'm going to call the u equal 8 times sine of theta. Then du is going to be 8 times cosine theta d theta. So by substituting this here, this integral is going to change to times. So du is 8 times cosine theta d theta over, and this is square root of 64 minus 64 squaring du. So this will be 64 times square theta, which then I move the 8 here. So 8 times 8 will be 64 cosine theta d theta over, and I can just factor 64 here. This will be 1 minus sine square theta square root. That equals 64 sine theta d theta. Square root of 64 is 8. And this 1 minus sine squared is cosine squared. And the square root of cosine squared is just cosine theta. And these two will cancel each other. So we'll just get 8 d theta. 8 d theta is just going to be 8 theta plus c. So now I just need to find theta, and from here, so divide both sides by 8. That's u over 8 equals sine of theta, and then just take the inverse of both sides. So theta equal arc u over arc sine u over 8, u over 8, and the u is this guy, so you can just put it there. Just now u is this guy, so you can put it u back. And this is now finally, this is going to be 8 times. So you have an 8 here, so it's going to be 8 times 8 ln of x, and then this is going to be your final answer.